So 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 this week we will be so this week, after we have completed deploying our ERC20 token, we will be able now to learn about crypto exchanges and decentralized application. So we will be like, this will be like our last lesson. That is cryptocurrency exchanges and decentralized application. So we will learn the different types of crypto exchanges. What are crypto exchanges? We learn the types of exchanges. We will also learn how different different exchanges work, especially for those for the DeFi projects, and also for the centralized exchanges. And we will also learn how. So you remember that in our previous lessons, I had mentioned about custodial and non-custodial wallets. So the same thing happens for cryptocurrency exchanges. We have those exchanges that control your private key, and then there is the decentralized exchanges. So I know you have had interacted with different exchanges, and you know the functionalities of different exchanges. You know how to like place an order and that. So I normally say that I'm not a trade analyst. I don't do trade analyst, so I wouldn't. So my advice won't be financial advice. Yeah. So, and always do your due diligence when it comes to investing in cryptocurrency. Know the things that are required, and know things that be able to like differentiate the different trades. Normally, I say that do not trade with the emotions. Don't trade with emotions, because people trade emotionally. And they trade because somebody has said so. So do your own research, not because Aaron has said, but Doge is the next big coin. Do your research, see whether the coin has utility, see the developers behind it, see the projects this particular coin is doing, and such stuff. So we have already seen what coin does in our lesson 6. That was on Ethereum token. So we were able to define what Ethereum tokens are. We were able to see the differences between tokens and coins. And we were also able to see the different types of consensus mechanism. And so what we haven't looked largely, or what we haven't looked into deep, and I think as we finish up with the ERC20 token development, it's a good thing that we do understand and see how we can be able to install the development tools in our system. Is we actually mentioned them, but we haven't used them, and we will be using these particular tools in our next lesson, that is on DApp development. So we talked about Ganache. And Ganache is a world-class development environment for testing framework and asset pipeline for blockchain using the Ethereum virtual machine, aiming to make life as a developer easier. So Trafo is a testing framework that actually is easy to use. If you have seen when we are developing smart contract, it's really hard to actually do a lot of testing on limits. And yeah, so we have Ganache. Ganache is a personal blockchain for Ethereum development. You can use to deploy smart contracts, develop your application, and learn, test. It is also available as both as a desktop application as well as a command line tool. It was formerly known as Test RPC. So you might have seen me, heard me talk about Test RPC. So Test RPC is the new name. Ganache is the new name for Test RPC. It's available for both for all OSs, that is Windows, Mac, and Linux. Yeah. Then we have Drizzle. Is a collection of front-end libraries that make writing dApps all for front ends easier and more predictable. The core of Drizzle is based on a Redux store. So you have to access the spectacular development tool or spectacular development tools around Redux. So if you are familiar with Redux, Drizzle is compatible with it, and it's better it's easy to use because these are libraries that are already created for you. So we will go to their website and see, and I'll also paste the links in the chat below, in the chat, so that you can visit them later and see how you can be able to use. So documentation is the key for every programmer. It's like a love note for programmers. Yeah. Then we have actually had a chance to experiment with Solidity and see how we can be able to write our smart contract. Viper, for those who are in Python and they can use the Pythonic programming language for creating smart contracts. Then we have interacted with MetaMask, which is a Chrome extension wallet to interact with dApps. Then we have truffle boxes. Truffle boxes are package components for the Ethereum. So we have something like create React app, which is a truffle bot, which is a kind of a bot or a bare bone. They normally call them bare bones, or we normally call them bare bones. So bare bones is like a skeleton of an application, and then you now start molding from that box. So it's like a scaffold. Yeah, normally some application actually tell you to use scaffold. For when you are creating a building, you normally use scaffolds to help you build the building. So it's the same for truffle boxes. So these are packages that have already been created for you, so that you can be able to develop. I'll show you one of one truffle bot that has already been created, and we can see how we can use it in our next lesson. That is on decentralized application and exchanges. Then we have crypto tax. Is a Linux image ready to be imported in VirtualBox that includes the development tools as mentioned above. And then we have Hard Hat. So for Hard Hat, we have Hard Hat, and we have Brownie. Brownie is for Python developers, and Hard Hat is for JavaScript developer. So it's a flexible, extensible, and fast Ethereum development environment. Yeah. So then we have OpenZeppelin. OpenZeppelin starter kit. This is the library that I showed you, or I shared the link with you in our previous class. So these are all-in-one starter box for developer to use when they are creating smart contracts. They normally include libraries, utility packages, a scaffold of an ERC20 token, a lot of ownable contracts. They have a lot of packages. So you can actually install OpenZeppelin as a package so that you are able to use it. I'll show you when we will be creating the decentralized application. So instead of creating the Ethereum contract or smart contract in limits, you can actually create them in your local machine without the need of visiting limits, because it will be easier because you won't be using a lot of internet, because limits really uses a lot of your internet. Yeah, so Open Zeppelin is they include Truffle. It includes Truffle. It has Open Zeppelin SDK and the Open Zeppelin contracts Ethereum packages, and then EVM package of audited smart contract, React app, and Limbo for easy styling. Yeah. So that was on tools. That was on ERC20 token tools. And yeah, so I'm just trying to do a recap of what we did last week, so that we, without much or a lot of, without wasting a lot of time, we can be able to finish up on the development of the ERC20 token, and then we deploy it. And then we will also have a chance to actually create our environments in preparation for the DApp class. Yeah, if that's okay. So we also talked about last week. We also talked about what are ERC20 token, the major functions. The major functions or rules that are followed when you're creating a simple an ERC20 token. So we have the name, we have the symbol, we have the decimal, and we actually defined what all of these rules do. So we have optional rules and we have mandatory rules that your ERC20 must have or must abide to. But I normally say that it's important to actually put the 3 optional rules, because just in your mind, just make it mandatory. Make it mandatory to add the name and the symbol and the decimal of your ERC20 token. Because alternatively, the identifier of your ERC20 token will be the contract address, of which it's really bulky to remember that address. Yeah. So then we have the balance of, we have the total supply, we have approve, transfer from, allowance, and yeah. We also talked about the advantages and disadvantages of an ERC20 token. And then so ERC20 token are easy to create, and also they are easy to implement. And then we have the disadvantages. The more they are easy to actually create, they kind of have the worst tokens, or they are the worst tokens. They are the worst tokens. Yeah, because anybody can come up with an ERC20 token and then deploy on the network and start selling the token. So that's why we have a lot of ERC20 token. And then there is a bug on the transfer event, on the transfer function, though there have been some audits and done, and some updates which have been able to be done. So there are a list of other tokens which are coming up. The central bank cryptocurrencies, and also we have what they call stable coins. So stable coins, basically they are ERC20 tokens which have a backing of another currency, especially either the fiat currency, that is the USD, or other cryptocurrencies, like what Daicoin is all about. So Daicoin is backed up by other currencies and coins, Ethereum, ETH, Bitcoin, Doge. Those are some of the examples that back up that make DAI a stable coin. So these days they call it SAI. SAI, it's stable. stable coin. And then we have something like $0, which is backed up by the US dollar. And then we have Euro, which is backed up by the euro. And we have titanium, which was backed by iron something, the one which Mark Cuban had invested in. Yeah. Then yeah. So there's something that I also kind of remembered as we talked about blockchains that are integrating your, they are kind of integrating your mobile phone into the wallet. Yeah. And then there are some smart contracts which are called escrow. So normally what happens in something like Zero blockchain has a way they have integrated. I don't know if you guys have Barora wallets. Hello? Hello?
I'm hearing you.
Yeah.
I'm here.
I don't know if you have Barora wallet. I don't know whether I can be able
Sorry?
to share Barora wallet.
But what?
Barora. Let me share you. Let me share the app here. Yeah. So if you are looking to holding something like Zero or Euro or $0, Barora or Baroha, call it Baroha. Barora wallet. Yeah. So this is Barora wallet, and it's a mobile payment application, which Kotani has integrated it in such a way that you can be able to use your USSD and then transfer the cash into your M-Pesa account. So so you can actually receive money using your mobile. Let's just go to the screens which are provided on the App Store. Just looking at the. So instead, it has access to your contacts. It has access. If you give it access to your contacts, yeah, here. Not there. So interesting. So I'm seeing that you can also be able to spend on Airbnb, which is really amazing. Instead of having to carry cash, or if your M-Pesa don't have cash, you can be able to pay your Airbnb. Yeah. So this is how it looks like. So the wallet or the Ethereum wallet is connected to your mobile app, Normally, the way you do the way we do sign in with Google to sign for something, for an account. So in Varoha, you can sign in using your mobile number, and then your mobile number is connected with the Ethereum account, and then you can go to your contacts when you are sending, and you can be able to send me, so long as, or any person in your contact, so long as they have a Varoha wallet, they can be able to send. They can be able to send you $0 using the mobile phone, and then they have an escrow system. So if that particular someone has not opened an account using their mobile phone number, then the money is stored in an escrow for like 2 days. And then if they haven't opened an account in 2 days, that money is returned back into your account. Yeah, so to avoid what we were saying about sending into another account and then the coin being burnt to the zero to the Genesis address. Yeah, so that's on such applications or such blockchains which are really revolutionizing the way we send money. Yeah, so yeah, that is it. So if you are looking to be part of the Zero ecosystem, you can be able to follow Valora app. And yeah, I've also shared a link. Uh, let me share it again here. And then, yeah. So this one you can register and then come and join. You can join this crowdcast. So you can join this crowdcast, and then it's happening tomorrow. See the Zero CTO talk about the DeFi in mobile applications, DeFi in mobile applications. Yeah. So yeah, that's on. Yeah, that's something that I just remembered. I should share with you. And yeah. So that's what we did last week, and this is that. And I've also talked about what we will be expecting this week and what we'll be able to do this week. Yeah. So it's like a marathon, because wow, can't believe that we are finishing up. We are about to finish up. Also on the dev virtue, I've added some assignment. So some of these assignments we will do together. I'll help you. I'll give you guidance on how to do them, and then you can attempt. Especially for number. So number assignment. Assignment not for assignment. I'm looking for create a, yeah. So for like assignment 6, you can create a Binance account and do a buy order. That one you can be able to do. And then we have create a simple erection DApp and deploy to a testnet. So this one I'll help you. I'll help you on how you will be able to I'll guide you on how you will be able to create and also deploy to a testnet. Then we have assignment 5. Assignment 5 is just a complete ERC20 and deploy to a testnet and also share your address. So today we will be doing that, and then this will be so then you will be able to do it on your own. And then we will then assignment 4 is create a simple smart contract to store, display, and send data. So this one you can create the ones that I shared with you, the code for GitHub, the one that I shared. You can refer to the GitHub code and create a simple smart contract that stores and sends data. So that is implementation of getters and setters. And also research more on Ethereum smart contract and come up with a simple contract of your own. Yeah, with a simple smart contract of your own. If you are able to do, you can come up with the standard functions that make up an ERC20 token. Yeah. Then this one will be built for lesson 5. So we are actually at lesson 6. We are completing on lesson 6. And then this week, and next week, 2 to 3 days, we will be doing a lesson. Okay, this is interesting. This is supposed to be lesson 7. Oh, I know why. I know why it's confusing to me, because there are some assignment that I combined. Yeah, there is this other assignment on double spending. This is what is research on Ethereum contract display send data. So that is lesson create a simple research. Yeah, that is on lesson 4. There is a question on what is double spending in blockchain. So yeah, you can try, you can do the simple one, and then yeah, then we can share in class. And yeah, so without wasting time, let's just dive into, I know it's a Monday, we shouldn't start with coding. Yeah, but yeah, let's just start with coding. So yeah, so let me open up my shoot this. So let me open up my so let me open up my terminal, my code, and then we can get started. Yeah, so okay, and then yeah, streams, contracts. Yeah, so and then we have token. Yeah, so just like is a custom or a norm, we will open our limits IDE. I lost some data. We will have to redo the code again, and yeah. So like it's our custom, we will go to link pay testnet, and then we change our wallet to the wallet that has the test ethers or the fake ethers, and then yeah. So we will create the ERC20 all, just give it a fancy name, like ADS token dot SOL, like SOL, and then we will have the pragma. So you can always copy. Copying is allowed. That's what my instructor used to say. Copying in programming is allowed, so long as you are able to implement your logic. So your logic is the key, because system can never be the same, but the logic can never be the same, but the code can be the same. So we have our pragma. So we had defined, we have to define the contract name, which is ADS, which is the ADS, that is the name of our contract token. And then we have Yeah, so we have string variable, which is, I'll just copy and paste, which is the name of our token. So this is our name of the token, which is, you can use double quote for strings, and then it's ADS token. You can use a space like that. And then don't forget your semicolon. Then we have the other string, which is also a public string, which is public symbol, the symbol of a coin, that is ADS. ADS is the symbol, so don't forget your semicolons. Not semicolons. Then we have the other string, which is also not a string, but a uint, an assigned integer, or an integer. That is the decimal, which is 18, and then we have total supply, which is not assigned or not given. Then we have the mapping for our addresses. So we have a mapping for our addresses or balances, balances of our token. So this one will be tracking so track balances should be immutable, should be exposed for public view, and also it should be positive. So this unassigned variable, most of them are positive numbers, and it should be positive numbers. So you should never have negative balances on the scale. Yeah, because we have numbers from our number line, we can go up to negative balances. Like there are people who have negative values in their account. Yeah. So then we have the mapping for allowances. So this one is should track how much the exchange is allowed to spend. So mostly this one is for exchanges, the allowance for. And then first address is the deployer, and the second address is for the sender, or the allowed, the one which has been allowed allowance. I don't remember what I was writing in that comment. The allowance is for the allowance. Then we have the event to send the token, that is event transfer. So event transfer is used to send the token or the currency, and you have to emit that event. So it normally has an address of the sender, and an address of the receiver, and then the value that has been sent. So it's important to use this to declare these events and mappings on top of your smart contract, following the way you want them to be compiled by the Solidity compiler. So we have approved tokens. It's an event or approval. So this normally is approval are the tokens that have been approved tokens for use in the exchange. Then we have the constructor. So in this constructor, we can pass different variables. We can pass different variables, and we can assign values to these variables. That is, and it should be public. So we can pass the total supply and set the total supply of our contract there. And then, so it should be 1 million token. So it should be 1 million token. And then multiply it by our decimal. So our decimal is to base 10 or base 10, which is the binary. Then we multiply it to the power of it's base 10 to power 18 decimals. So our total supply will look like this. In short, it will have decimals like this. So if we want to send like, it will have like 18 decimals. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. So in short, our total supply will be looking like this. So anybody who has like below this 0.000, like something like that, this will be like our units. This will be like our ADS, or we ADS or something, yeah, like the smallest unit. So the smallest unit will be smallest small unit. That will be the smallest unit. Yeah, small unit. So that is the in power. And then yeah, then we have balance of. So balance of should be passed and at the balances of. So this one is in an array. So it's in an array because one, we really don't know the message.sender, because any sender can have a balance. So anybody who will own the coin, like the total supply, or has a balance of the total supply will be displayed here in the mapping. So will be exposed or displayed as a public view there. So we normally put the sender. Anybody who will have a share will be in the ledger. Yeah. Then we have the function, the actual function that does the transfer. So this one we have the function transfer. So function transfer is the actual function that does the transfer of the token. So the function has two parameters. Because it has two parameters, that is the receiver and the value, and it returns a Boolean which is true, and it is supposed to be public. So it returns a Boolean which is true if it's on success. If it's true, if it's successful, it should be true. Else, if it's not successful, it should return a Boolean which is false. So true or false. And then you have to require the balance of the sender, the balance of the one who is sending. So it's also in an array, or it's in an array because we have a lot of addresses that may have the balance of this particular token, like our ADS token. So we may have a lot of holders of token who holds our token, and then we really need to check their balances. So message.sender is a global variable, and it's an inbuilt variable in Solidity. From our previous lesson, that is smart contracts. We are checking whether it's greater or equals to the value. So if the balance of the sender is greater or equals to the value, then you give the sender the chance to transfer. So we have an internal function here called function transfer, which we are calling, or we have been able to use. So in OOP, there is what we have inheritance and it means that a function can be able to inherit the properties of the child function or something like that, if I can remember from the definition of inheritance. So you can be able to inherit or you can be able to use a function internally in a smart contract. So this function, which is an internal function and can only have internal use only, it can only be used internally. So this one can be used publicly because it has the public keyword public. So this is the internal function, which is the transfer, and it's normally it's written in an underscore. And we have a transfer from to as parameters and value. So we have actually inputted the from as message.sender. So the address that will be sending will be inputted there, and then you will have to input the value of the receiver and the address of the receiver and the value of you are sending. So the function transfer takes in 3 parameters, that is from, to, and value. And then first of all, you have to check if the sender has enough balances. So this one, we moved it here. We moved it here. So this one is supposed to also be there. You have to check. So require. So require actually means it's just the normal ways that you have to require. It's a requirement. And then return, you have to return a value which is true. So then we have another thing, senders balances. So this function should also reduce the balances of the sender and increase the balances of the balance of the receivers, and then it should emit an event transfer. It should emit an event transfer. So this one, you have to require the balance, the wallet of the receiver. So if the address is null, the transaction will go to the 0th address, or yeah. Then we have balance of, which is from you have to check the balance of and get. So this one is for reducing the balance of the sender, the balance of the sender. Remember the library that we haven't imported, that is SafeMath. SafeMath is a library that is used for calculation, and we will actually get it from OpenZeppelin. Then we have balance of the receiver. So we should increase the balance of the receiver once we have subtracted the value. So this value should be increased, and then we should emit the event transfer with the 3 parameters from, to, and value. Yeah. Then we have the two last functions, which are also mandatory, and that is the approve token for use. So this one is a function for approve token. You need to approve the tokens for spender. So you have 2 parameters, and that is the first one is the spender and the value, and then you have to require the address of the spender. So these are logic operators. If you can remember, these are logic operators. The same case here it's a logic operator, the same here. If you can remember from the previous class, that was on solidity. So we have allowance, then from the mapping, we have the allowance from the mapping, and then this the sender's allowance. So this is the sender allowance. So you have to, it's in an array because we don't know about it. We exactly don't know the address that we will be allowing. Yeah. Then we have the spender. The spender is also in an array because we don't know who will be allowed to spend all the tokens, who is being allowed for that. And then we have the value that they are supposed to be allowed to spend. And then we have emit approval. So emit approval has three parameters. From here, we have the owner of the contract, we have the spender, and then we have the value. So this normally, if your ERC20 token has been listed on the exchanges, let me show you an example on how it normally happens. So if we So if we take a look at this contract, the Ubricoin, we have this transaction going to Uniswap. So from what you can see is that this contract, the way it has moved, it moved from this particular address to this other address, and then it went to another address for version 2, and then it went to another address, and then it was from the contract, the Ubricoin contract. So yeah, so these are all the actions that have been used to do the transfer. So these are all the events that has been used to do the transfer. So, and as you can see, this transaction is a EIP 1559 transaction, of which it's awesome because the base fee, as you can see, the base fee has actually reduced. And then the maximum fee per gas, the fee per gas. See, this transaction has reduced. The transaction cost or the transaction fee is quite great. Yeah. And then the gas price, you see, yeah. So this is amazing because if we take a look at another transaction that happened earlier before August last week, take a look, like the transaction were crazy. They can do like 15 days Uniswap, 15 days Uniswap. So you can do a comparison and see. So this one was not an EIP 1515, and as you can see, the transaction fee was $7. $7. That's 700. And then the amount of coin that you are swapping so that you can get this is quite low, because it's actually $0.00. So you are paying 700 to paying 700 or $7 to get $0.00. Wow, that was 15 days ago. But for this one, which happened 8 hours ago, how much are you paying? So transaction fee. Try to see. So this one is around it's a big figure. Okay, it's what it's double 8 plus this one. yeah, it's worth it if you are paying 25 to get this amount. It's worth it if you are paying 25, but still there is more that needs to be done. So I guess they are still doing it. So it's worth it if you are getting this amount. So they were getting 1,000. So people are buying it. Interesting. People are buying UPN. This is interesting. This is awesome. They are buying a lot of UPNs. Yeah. So what we have written here, like the balances, these balances, it will also display the holders, the transaction, the token will, once we have deployed our token, so the maximum total supply will be displayed here together with the token symbol. And then we will have the contract address here, and then we'll have the decimals. And then we'll have this one are added later once you have deployed your contract. The social medias on social profiles, transfers. These are all the transfers that we have been able to map here. This one, the events that we have emitted there. So yeah, then the last three, we will have the holders as the mapping of the addresses. So any wallet that has a balance of UPN will be displayed here. So if you don't have a balance for UPN, then it won't be displayed here because you actually don't hold. And it will be bad if we display a wallet that does not hold any UBNs here or any ADS. So we will see that in a minute. And yeah, so that is approved. And it should also, it also has a Boolean, which can either be true or false, and it should return, if it's successful, it should return a true value. Yeah. Then we have the last function, and that is transfer from, which is mandatory. So transfer from is a function to transfer coins on behalf of someone. So it has the same parameters as transfer, because it's basically transferring. So you have to check the value of the tokens, whether it's greater or equals to balance of the one who is transferring. And then you have to check whether they have been allowed to transfer. And then you have to put the message.sender, because we don't know the address of this particular person. And then you have to reset the allowance. So you have to reset the allowance to 0, so that you don't like, so let's say you are allowed to like spend 20 shillings today. So if you spend the 20 shillings, we will have to like reset to 0. It's the same thing for a water tank. The water tank have like kind of have a sensor, and the sensors sense when the water has reached a particular level, and then it initiates the other sensor to kind of switch off the tap, because that is enough water for today. The same thing for allowance. So it tells it returns, or it sets the allowance to 0. So it subtracts the value to so that it can be able to reset to 0, so that you don't like have a continuous loop whereby you are spending all your currency. Imagine when you want to share your M-Pesa, your mobile money cash, and then it is set to spend. So you kind of like spend a lot. I hope you are understanding what I'm trying to say. Yeah. So what we don't have, so these are complete these are complete so these are complete ERC20. The only thing which is missing is so the only thing which is missing is the see what is the safe math. So it's the safe math. So I'll import it from Open Zeppelin. GitHub. Then let me share this link so that we can be able to use it. Yeah. So this is the utility content. The Open Zeppelin library or starter kit that you can be able to use. Then we will just move into, should be in token. Should be in token ERC20. Then we have utilities. Save ERC, not there. Access. So for access, we have this one, ownable. This is something that we will also add. We can also add so that we can be able to see who can actually own our contract. Yeah, the only person who can be able to own our contract. So governance, works, utilities. I think it's in utilities, and then we have math. Yeah. So this is another one for escrow. It's an escrow contract. So we will copy this one. So save math, and then we create, console, and then enter, and then we will just copy. So there is a way you can be able to like import it from Open Zeppelin. Let me see if I'm able to like get smart. Chain link. It's called chain link. Chain link GitHub. Chain link GitHub. So we'll just paste this one. So this one you don't need to like memorize or cram or anything, or just know it's already done for you, and you just need to copy it or import it as a package from Open Zeppelin. So I'll show you that in the next class, which we will be starting it tomorrow. Yeah. So after that, we will do the import. So remember how we did the import and contract inheritance. So we import save math. So and then with should be a forward, and then we will using uint, using safe math, save math for integers, for integers only. So this one will work for numbers and not for strings. Will work for unassigned integers only. Then we'll go to our compiler. We'll set a compiler version to 5, and then auto compile, and then hide. So it will automatically select the best compiler for us. And then Let's just wait as it compiles. So let me, so this is the chain link. So chain link also have a way that you can be able to do Mumbai, Kovan, Fuji, Link Bay. Yeah. So these are way you can be able to do your testing on chain link. And they are doing something amazing with oracles and such. Yeah. So I think like developer is the best way. Like it's like documentation is like I don't know what I can compare documentation to. They are amazing because you just have to read the documentation. So we have ENS for smart contract. We have another one for. So this one we will be able to see how this one work, like how Web3 works. We'll be able to do that in our next class. This is the smart contract. So Web3 is for interfaces. Let's see if it has compiled. So we have a program. So contracts. So I'm not sure where is the oh yeah. So we forgot a semicolon on line 5. And then we still have a problem. See, so you have to use the same compiler for your contracts. Same compiler for your contracts, so that yeah, awesome. So our contract is good. Yeah, our contract is so these are just warnings. These are just warnings. So warning are not harmful. So if you see a warning, don't panic. Errors are the most. You can panic when you see an error. And then there are good errors and bad errors. So good errors are the errors that are telling you that you have missed a semicolon or like something. They give you information. So we had already done some testing on this contract. So today we will be actually deploying it into a test net. And then so what I will do, I will inject Web3. And then we have already been able to select that we are on link bay testnet. And then what I will do, I will just deploy. So I'll just deploy, and then we'll be able to see confirmation. Yeah, so we have already injected Web3 into so that we can be able to call MetaMask. So it's in link bay, and we have the gas price and the amount, and then we need to confirm. So contract creation is pending. We'll just go to let's see our contract deploying. So, just a minute, let's see if it works. So it should, yeah, nice, awesome. Yeah, it was successfully deployed. And then, so what I want us to do is to, so this is our contract. So this is our contract, and this is the transaction. And then the name tags are not available. So what I want us to do, or what I want to do is confirm the contract. So I'll verify. So compiler version is a multi-part file, and then it's a multi-file. It's a multi-part file because we multi-part files. So we have created different files here. So we have this one, which is ADS, and then we have the safe math. So they are different files. So what I will do, I'll also select my compiler, which is 0.8.0 plus, which is a commit. This one. So this one, this is our compiler. Yeah, we have selected the right compiler, and then we have license, which is MIT. Then we will continue. And then I'll save my file so that I can be able to like choose no file which is chosen. So I'll have to save this file into my machine so that you can be able to deploy them. Then okay, so it's the safe math here. Then control S. Save. So then we have the other one, which is ADS. Then we have so we have control X. It will also be on desktop. Save. Then I can be able now to choose. So we'll choose our files, which are on desktop. The first one is ADS. And then we have save. Oh, click. Sorry. Oh, I expected so. Let me select them continuous. Like, so we have ADS. So there is a contract that I was trying to create. That is an anathon. Anathon is where you need an yeah. So we need to upload. So we have already added our files, and then we need to then verify and publish. So sometimes this gives you headache when you are verifying. Hope. So if you want to be making it abstract, sufficient is sufficient. But that's here. So this part normally one invisibility of our constructed. So let me see. It's supposed to safe math is okay. Safe math. Oh, let's see. So safe math is okay. So safe math is okay. So you can start all over. Let me just do something. Instead of importing there, I'll just copy this entire code here. The entire library here. This one. Then paste it. Yeah. And paste it there. Yeah. And then I will make just see something. Just a minute. So just a minute. Just a minute. Okay. Okay. Fabric. So we can actually leave it like that. Let's not leave it like that because we have already deployed. So let's start over. So this one is yes. Okay. Okay, before we actually confirm, let's just do something, and because I've seen it will take a lot of our time. So this is our contract, and let's just add it into our MetaMask wallet. Because I wanted us to confirm so that we can be able to see the token information in the scan. So we will have to add our Okay, let me share this other side. Screen one. Yeah. So we will add our token here. So below there is add. So we will add the token contract, and it should automatically add. So you see, so this is what we have done. And then we'll go to next. And then so since I'm the owner of the contract, I have all these ADS tokens. So let me stop, and then we go to the other screen because this one is a bit bigger. Which screen am I sharing? Oh, it should be two. So it's a bit bigger. Yeah. So share. So as you can see, we have actually created our coin, and we have ADS here. Let me see if I can view on EverScan. Yeah, on EverScan we will be able to view. See view. Oh, expand view. Yeah, it's expand view. So from our expanded view, we can be able to now see that we have ADS token. And since I'm the owner of the contract, because we had not specified who is supposed to have or where the coin are supposed to go. So they never went to the contract. They never went to the contract. So this is the contract creation. So they never went here. They never went here. So we can actually send some coin to the contract address, And then there is something that I want us to see. So this is the contract that has been created. The moment you deploy, you have a contract that has been created. And then we have this input data. So this is the data that we have. We have sent once we have created our contract. So I'll do a transfer of this ERC20 token that we have created. And yeah, so I'll send it to the contract address and see how they interact. So send ADS. I'll add wallet there, and I will send like 10 ADS to the contract. Then there, so confirm. And then let's wait for the transaction to be confirmed so we can be able to view the transaction. And we will be able to see the kind of event we have actually. So it's not okay. It's not a must that you do the verification of code, because in Zero blockchain you don't need to verify, because this code is automatically, when you deploy, you are deploying to the EVM. You have deployed that code to the EVM. Yeah. So yeah, it's taking a while. So when you have deployed, it's not a must you verify, but it's good. It's good because it also shows you in Ethereum, when you confirm your smart contract or you verify your code, it means a lot. So this, we have been able to do that. So our tokens have been transferred. So we have transferred from this particular address to the smart contract address, and this is the 10, the value that we have sent. So this is the event that I was talking about. We have to emit the event. We have to show the balances. We have to show these 3 parameters, the from and the to the other address, and then for how many coins have we sent. So we have sent like 10 coins. Yeah. And then we have triggered this function. We have triggered this function transfer, which has the value, the address to, and the value. So this is the function that we have triggered. So this is the function we have triggered. So we have triggered this function. And if we dig deeper into, then we can be able to go to our contract, and we will be able to see now the contract has a tracker, because now it has the value, it has a holder. It has like two holders, see? So it has the two holders and it has one transfer. We only have one transfer because we have actually made one transfer from this address. And then we have the total supply. So this is what we are looking for. So we have a total supply of 1 million ADS, and then we have two holders, and then we have one transfer. And then we have, so here we can be able to track the holders and the balances they have. So we have this token, they are two holders, and they have, so the first one is the contract address, which has 10 coins. And then this other one has 999. It has a percentage of 99.99%. So yeah, so this is how you are labeled. And then you can see the overview, which states that it's an ERC20 token. And yeah, so this actually marks the, okay, sorry for like not being able to verify, but you have basically seen how you can be able to verify the contract. But yeah. So you have seen how we can be able to verify the smart contract, even though it hasn't worked in our favor. And we have been able to like create a free-fledged ERC20 token. It's a simple one. It doesn't have a lot of function. So we can in our next class we can actually do more on the contract. We can add function ban. We can add function ownable. We will add another smart contract that is ownable. Let me try to verify again and see if it's going to work, because we have like a few minutes. Let's verify. Single file, compiler, and then we have license, which is MIT. And then we can continue. Let's see, it's optimized, yes. And then paste our code there. And then we submit. So let's see if we'll be able to verify, so that we can be able to see some of these functions like transfer and yeah. So it's interesting. Okay. Let's just be fulfilled that we have. Let's just be happy that we were able to deploy. And yeah, I'll check on this, because this is a warning, and it shouldn't actually prevent us from submitting. Shouldn't prevent us from submitting.
But since we are getting the same warning, whether it is multiple or single, I think we should go back to the normal way, as in you have the safe math on its own.
Yeah.
You just call out the function, then the ADS contract on its own, because right now we are still having the same warning.
Yeah,
and
yeah,
it's coming from the ADS token contract.
yeah. The first one is coming from the constructor. This one.
Yeah.
So it's something. Let's see if I can be able to check and see how whether they hasn't they haven't actually upgraded the. So there is this forum you can be able to. So how to get rid of visibility? Is it not? So in the latest compilers, the contract, the so if, it looks like it's something that has been. It looks like Trafo uses a different Solidity version, so they fix the version code. So both use the same version using that. Oh, so I can remove the public. Let me see if I remove the public, whether it will work. See if it will work. But yeah. So that's actually kind of concludes our what code we are looking for. So okay, bytecode does not really match. They don't match. They are not matching. Let's change. Let's deploy these ones again. So we'll change the name to ADS coin and redeploy again. ADS coin to deploy again. Then coin. So then as we deploy, okay. So optimize compiler version. We are using 0.6. We should select 0.8. We should submit it to redeploy again and see. So coding sometimes is a little bit hectic, and yeah. So meanwhile, you can send so you see we have the minus. We were able to like subtract the value from some minus. So if it's a plus, it will show us an addition. So meanwhile, let me share the contract of this one, and then you can add into your MetaMask wallet. And then you can share your wallet, and then we can be able to share some coin. So in another world, we are very rich. In another network, we are very rich. In a test network, we are very rich. So let me deploy. Then this time it should work. So in another network, we are rich. So I've shared the contract link, and then I can send you some tokens. Hello. Yes, I've shared the contract, so you can add it to your wallet, and then I send you some tokens, and then we can yeah, so that we are able to finish up. So okay, so this is the contract we have deployed, and let's do another verification. It should work this time. Single file compiler version is 08. And MIT. And then you can share your wallet on the chat. Sharp. Yeah. So the compiler is today. And yeah, awesome, nice. Yep. So our contract has been verified. So disregard that other one, and then we will use this one. So we will use this one. We'll use this one. Yeah, interesting. Yeah,
so
nice.
it took the ADS coin instead of token.
No, not. I was giving it another name so that there is no conflict of names. Like this one is token. This one is token. I've actually not changed a lot. I don't know why. I think it wanted us to like deploy it when it's a single file like this. So there you can use this form of deployment whereby you combine all the contract. So the one which is being inherited should be above, just like the way the normal inheritance. So our grandfathers are above us, and then we are inheriting from them. So yeah. So in our next class, we will at least add some few things. I know it's a lot of words like to comprehend in one day. Yeah. Yeah, but I'll share this entire code on my GitHub link right now, and in my GitHub, and then you can pick it from there, so that you can be able to like experiment on your own as we move on to like completing this one. So this one is just a simple token that we can be able to test that we can be able to like use, but there is a complex we can make it more complex by adding bannable functions. Let me show you from OpenZeppelin some of the things that we can add to make our contract more secure and more strong. So we have access. So for access, we can add ownable. We can add ownable, and then there is access control. We have enumerable control, access control contract module that allows children to implement a role-based access. So you can create a role-based access the way we have admin members, yeah. So you can be able to add those types of roles. in your smart contract. So you can have admin. If somebody has a role, the same way you normally do. So you can get role, you can grant somebody a role. Yeah, so those are, you can revoke somebody's role. And the only person who can be able to revoke that role is if somebody is an admin. Yeah, the normal role, user-based roles that are available in WordPress. It's the same. Somebody can be able to renounce role, can renounce your role. You can also be able to like set admins, set roles, yeah, revoke roles. You can change role. So to give you an example of a contract that has such is Gitcoin. Gitcoin what? Gitcoin Stewards. Gitcoin Quadra. Yeah, Quadra. Not Quadra. I think yeah, this one. Yeah. So they have governance mission. So this token, it's token distribution, the way the token has been distributed, and some of them has been allocated to different governance. So we have for disclosure forums, different different governorship. So we have this one for empower a steward. We have this other one for postcard generator. This is how they have distributed their token, and can actually go to, you can actually go to Etherscan. Let's just go to etherscan.io, and then we can be able to take a look at. So you can discard this one and use this one. So let's use this one as a example. So add that one into your wallet, and then we can use that one. Yeah. So if we go to Etherscan and then search for Gitcoin, yeah, there we have Gitcoin. It's the same for every coin. And then if we go to contracts and it's this other one. So they have the read. So these are dedication and checkpoint, and then we have the write. So a smart contract is a read write. Yeah. So they have delegation list, delegated on this, and then delegated by sign, and then we have delegated. So delegate. So if we go to their contracts, the code itself. If we read the code itself, they should have vulnerable. Yeah. So this the safe math. This the safe math. This the safe math. You see the safe math. This the Git. This the set Git token distribution address need to be called after Gitcoin token contract is deployed. So yeah, so then this is the mint function. So this function is the one used for minting, and only the minter can mint. So the person who has been delegated that role for minting is the one person who can be able to mint, and the amount cannot exceed 96 bits. So they have a limit that they can yeah. and it cannot exceed the mint cap. It should not exceed the mint cap. So the mint cap, the mint cap, this one is for spender approved amount cannot exceed 96 bits. This is the same function that we were talking about. So you can go to Etherscan and be able to check the different smart contracts that are available there, and then see how they have been able to implement. So, and you can actually experiment on them, and yeah, you have not been limited. You have not been limited. As you can see, these guys are using 0.6.12 as the unit. So those are some of the things that you can be able to add on your contract, like governance, access load based. You can also create an escrow contract whereby you can refund. So this is the contract Zero are using. So you can visit Zero, GitHub. Let's see it on. Then we check for Zero. So this one, I hope you have added and you have also shared your MetaMask wallet. So we go to Zero. So this is the Zero blockchain official for gold. So contracts. Check at contracts. You see, they have the epoch rewards. So this one is for giving new rewards. And then they have a freezer, and then they have gas price minimum, and then they have the token. Initially, it was called Zero Gold. And then we have the currency, we have the APIs. Yeah. So if we go into the token, this one is for Go. It's the same thing. It's the same basic thing. Get total supply, get increase supply. Yeah. So let's just use the one for Java. Java. So these are set of proposals. Need to see the one for Java. So TypeScript. Okay. I think it's this one. No. That is not the one. So the most I'm looking for the one. Okay, never mind about it. But yeah, they have that one for governance. They do have for governance. They have the one for elections. This one is for elections. Like the one for elections is normally used when you are doing voting on the blockchain, on the Zero blockchain. So yeah, it's the same thing. So if you are able to you are able to do this, you can actually be able to bend. You will be able to bend and use it in different places. So this one is for escrow, and yeah, the beneficiary should be immutable. So the same logic you normally have when you have deposit, and then you will enable refunds, so you can allow for refunds to take place, rejecting further deposits. So yeah, you can use this as a scaffold, and then you build on top of it. Yeah. So that's it. So let me add the this one we have been able to verify, and then yeah. So this is what we have been able to verify. Can visit it. And then we can add the token here. So yes, okay, we have closed the long one. Yeah, this is the one. 08. Yeah. So we will add this one, and yeah, then we have our tokens there. And then we can send, and then we send it to Ambrose. Ambrose. Okay, that is your added. Yeah.
Yes, I've sent you my
Wallet.
address.
Yeah. Okay, I've seen it. So I'll send like 10,000. I'll send like 10,000. Yes. Then we confirm. So you can confirm, you can check if you have received, and then we will send. So I hope this is your wallet, Nani. Damaris. This one 08F92. Hello.
Hello.
Yes. Yeah, I hope this one is. Yeah, is this your wallet address? Because this one is Ambrose's, and this is yours.
The MetaMask.
Yeah.
Let me confirm. OX. My MetaMask is OXE.
OXE.
Let me.
Okay.
Let me.
Okay.
I think I'm checking the wrong network. Let me go to Linkspec.
Okay. Okay.
I was taking my. It's OXE670. That's my Rinksbay test network.
Okay. Just send it.
Post.
Yeah, just post it there.
Am I going to add the AJ?
Have you received it?
Yes, I've seen it. Yeah, I've seen it. Okay, let me send you. Have you received the tokens, Ambrose? And that is 10. Yeah, 10,000. Yeah, you should have received 10,000. So in a private network, we are very rich. Hope this could kind of reflect in our accounts. Yeah. So I've sent you 10,000. And yeah, so that's how you create and deploy a contract, and also you verify a smart contract, and then so we can be able to like see the the functions that we have created. So we have approve, and then we have transfer, and then we have transfer. Yeah, and then if we now refresh our token and go to ADS token tracker, we should have 3 holders. You should have 3 holders. Yeah, should have 3 holders. Yeah. So yeah, this marks the end of our lesson on Ethereum token, and yeah, it was interesting. If anyone has a question, comment, concern, share. You can ask. Yeah.
I think I have a concern.
Yes.
In the parts where you are coding the ERC20 token, I think I always get lost where we start copy pasting.
Okay. Sasa.
I just naona two codes appear out of nowhere, so I think that's where I get lost.
Okay. I normally have to save us time. I normally have like already done the project, kind of done the project. Like for this one, I had already done the project, which I've tried and learned the, like I've been able for the sake of demonstration purposes, and then I always explain the code, what the code does. Yeah. So for that, for copy pasting, I think yeah, because if we start lighting from scratch, we can take a lot of time. Yeah. Yeah, but I normally explain the code, how it does, and I hope it's clear on the explaining part, like what it does.
Maybe in one of the free, maybe Saturday sessions, we can do one from scratch.
Okay, then we can do that. Yeah, on Saturday we can do that. Yeah.
I wrote my Python code, the one you prompt the user to import the message, and it worked. It's running.
Okay. We will check it right now. What about you? Yeah. Yes, you think?
I'll submit it in the assignments part. Is that okay?
It's okay. And you, Ambrose, do you have a question?
This code for this smart contract, have you shared it with us? Because I need to try it.
Okay, let me do it right now. Let me do it right now. Okay, I'll just do it casually. Will I do it casually? Let me share it on GitHub, and then so create. Should I add it on this ADS demo tutorials? I think I should add it there.
Yeah.
Wow. Let me just add it normally, because I want to deploy it ADS token. Just call it that. And then I will kind of delete ADS. Then I will delete. Yeah, and create. So if you have a GitHub account, you're awesome. And then import. So let me save it as one. So I can import it. So, if you are lost, if you are still interested, we can do the Saturday classes. Can do the Saturday classes. Yeah. So this Saturday I wasn't. I had a lot of things that I was doing. let me create a folder. Yes. So this is how you create a folder. Have created the folder. Just start the folder there, then it's init. So git init is for initializing the repository. Oh God, I've initialized it in the node. So we'll see D into our ADS token. And then we do it with our decimal means you add everything. Then we'll do git commit dash m. So it means you're committing everything. So you can just write single file, then you can actually put some emojis. Actually put some emojis there. Some emojis. We have added a lot of emojis. Have enter. So then we'll do git branch dash m, which means it's a main branch. So they removed, then we will do git remote and then git push origin new master. So paste there. Then S3, we have it. So let's refresh. Yeah. So we have our code, and then there you have the code. Now you have the code ambos. Now you have the code.
Okay. Okay. Thank you.
So you can take a look at it. You can play with the numbers. You can play with the numbers here. You can go check out other smart contracts available and see how they have been able to like implement, and and you can also check on the function ban. That one I can give you as a to do function ban. So check out function ban and see how you can be able to like ban your tokens. If you can be able to ban tokens. Yeah. So let's see what you have for us, Damaris. Let me make you a host.
Thank you.
Yeah. So let me make you a host. Are you still with us, Damaris? Yeah.
Yes.
So you are now a host. You can share your screen and let's see what you have for us. Yeah.
Okay. Can you see my pie chart?
Yes, I can see.
So let me run it again. So I can read any message. Is it okay?
Yeah, it's great because you have been able to decrypt, so we have been able to see the original string which has been encrypted, and so this one is it's the normal encryption. Is it using is it asymmetric cryptography?
I think it's I think symmetric.
Okay.
But I've not seen any part where we are inputting the public or the private key.
Okay.
But when I was checking the code, they were saying the file we installed on cryptography and Fanet, it automatically generates the keys.
Okay. Awesome.
Yeah, so maybe we can try together the one now you have to input the key to decode.
Okay. So interesting. Nice. This is great. This is great because yeah, this is awesome.
Thank you.
Yeah. So every day is a good day. Like you can stop the sharing and where do I claim my? You can yeah, you can make me the host again. I don't remember where I was a place where I pressed last week to reclaim the. Oh yeah, I've seen it. Yeah, I've seen it. Yeah. Okay, so yeah, so this have it has been an awesome class. So we can start again with you, Ambrose, and share what was interesting about smart contracts and ERC20 tokens. And what?
Sorry?
Yeah. So you can share.
You mean my own encryption?
Yes. You can share.
Well,
you can.
I already shared it. Okay.
No,
I already shared it before.
Okay, I mean,
sorry?
like you can share your experience on ERC20 token. What was new for you? What you learned? What yeah, what you didn't know and now you know.
Well, is now that from ERC20, at least I should to kind of create my own coin based on what I've been taught. And then, like I said, I'll still go through the code, although it seems to be user-friendly, the language used there. So then I think it's a good high opener. I think I don't know. I never knew that this how, well, will I say, how simple to write a code, a smart contract for coin. So I'll go through it, and then if there's any gray area, I'll definitely come back.
Okay.
Yeah.
Yeah. What about you, Damaris? Is there something new you learned, something you didn't know? And yeah. Yeah.
I think for me, every day I learn something new. But I think basically is majorly on Ethereum. That's the major part. And I've been looking into Ethereum this weekend concerning, we moved to proof of stake, I think, already.
Yeah.
Yeah, so I think that it's around that what I've been doing most of the time.
Interesting. Yeah. So it's great. It's always good to learn something and also reflect on what you have learned and see what you have been able to understand and also be able to comprehend. So this one is more like an introductory, and you can be able to get more resources. You can be able to learn more. And I normally, sometimes me and my brother, we normally go for introductory lessons, and then from there we can pick up. We can be able to pick up from there and experiment on different platform. Like we can now be able to explore. And normally when you graduate, they normally tell you now you have been given the power to go and read. And so in a few weeks I will be saying the same words.
Yeah, it will be very interesting,
Yeah. So in fact, you can also challenge me, and yeah.
No, you cannot. It's like a student trying to challenge the professor. We are still undergraduates.
in the kung fu movies, they normally talk with the sense, the master. They always ask for the but yeah. So right now you are way I think you are in a better position. You're in a better position. And when we started the class, we were all new. And so let's save this speech for next week.
It feels sad if the class will end.
Yeah. It is.
When you say that, it feels sad. Maybe we can extend kidogo.
Yeah, we can always have a class. We can always have a class even outside the DS. Yeah, we can always have. So long as we are communicating and everything, we can always have a class. Yeah, because sometimes yes.
Are we supposed to do like a test, an exam, or our lecturer will trust us we've understood?
Let me first of all post the recording. Question on the if you have a question on the smart contract, if you're getting an error, if you're getting a bug, just contact me, and you can contact, and then we can have like the first few sections of the class to try and debug. And so remember, coding is the best thing that you can ever do, because you are solving real-time problems or real-life problems that are impactful. And also remember that a project that you can start, or the project that you partake in, whether in blockchain, whether in data science, whether in analysis, whichever field you will be in, make sure that that project is something that is impacting community, because community, if you invest in community and if you invest in people, you are investing in a lifetime opportunity. Yeah. So that's it. And yeah, so yeah, you want to say something, Ambrose?
Yeah, it's okay. That is it's very thoughtful.
Yeah.
And well, as you said, coding is sweet. You know,
Yeah.
the moment, I mean, when you are, once you know what you are doing, it's just that it is starting as the initial bottleneck. And once you keep started it, you know what and what to move around with your, I mean, what you need. Then from there, life becomes easy for you. You know, it's just to customize the code to suit the purpose you are designing it for. And from there, you see the joy in it. No, it's a good one.
Yeah, exactly. Exactly. Yeah. So let's call it a night, and yeah. So have a great day. Not great day. Wow. It's a morning. It's a morning. It becomes a morning when we start coding. So have a great evening, and enjoy the rest of your evening. And yeah, good night.
And you too. And you too. Good night. Take care.
Yeah.
Good night.
Yeah. Also, before I end the meeting, if you are interested in getting to learn more, you can join the link that I shared and come and learn about Zero. So if you love Ethereum, you will surely love Zero, and it's basically the same thing we have done on Ethereum. It's basically the same thing we have done on Ethereum, and yeah. So goodbye. And
all right, goodbye. Thanks.
Good day.